Welcome back to Introduction to Software Reverse Engineering. In this module, we will reverse engineer two new example programs that showcase loops. These programs are pretty simple, containing various kinds of loops and nested loops in them. Let's dive in. In Module 6, we will take a look at various types of loops available in C and C++ programming languages. Loops are a fundamental construct in programming made to execute a block of code repeatedly. In this module, we'll review the different types of loops you'll typically encounter, including for loops, while loops, and do-while loops. In this module, we will explore how the loops are represented in compiled code and how we can reverse engineer them using Ghidra. The goal is to learn how to decompile loops, understand their structure, and identify the different types of loops even after the compilation. C and C++ languages provide for the following types of loops: for loops, while loops, and do-while loops. For loops are useful when we know exactly how many times we want to iterate. They consist of three main parts: initialization, condition, and increment or decrement. While loops, on the other hand, are used when we are not sure how many iterations we will need. They'll keep executing as long as the condition is true. Do-while loops are similar to while loops, but with one key difference: the code block is executed at least once before the condition is checked. This makes them useful in situations where we want to guarantee at least one iteration. Let's explore a key difference between loops: entry control versus exit control. For loops and while loops are considered entry-controlled or top-heavy loops. This means that all the initialization and condition checks happen right at the beginning, before the loop body is executed even once. In contrast, do-while loops are exit-controlled. They don't check the condition until after the loop body has been executed at least once. This means that the loop body is guaranteed to run one time, and then the condition is checked to determine whether to continue iterating. This fundamental difference in loop structure can have significant implications on how we design and use loops in our code. Let's take a closer look at the for loop. The syntax is straightforward: for, init, condition, increment, code to execute. But how does it actually work? Here's how it works step by step. First, the initialization statement is executed once, setting the stage for the loop. Next, the condition is evaluated. If it's true, the loop body executes. The code inside the loop is then executed, followed by the increment statement. The loop then repeats, re-evaluating the condition and executing the loop body and increment statement until the condition is false. Now let's explore the while loop. The syntax is simple: while, condition, code to execute. But how does it work? Here's the breakdown. The condition is evaluated, and if it's true, the loop body executes. The code inside the loop is then executed, and the loop repeats, re-evaluating the condition and executing the loop body until condition is false. A key point to remember is that the loop body may not execute at all if the condition is initially false. It's also crucial to ensure that the condition will eventually become false, otherwise you'll end up with an infinite loop. And finally, let's take a look at the do-while loop. The syntax is a bit different: do, code to execute, while, condition. So how does it work? The loop body is executed first, and then the condition is evaluated. If the condition is true, the loop body executes again. This process repeats until the condition is false. Do-while loops are particularly useful in situations when you need to execute the loop body at least once. Some common use cases include validating user input, where you might ask for input until it's valid, or situations where the condition depends on the loop body's execution. Now that we've explored the different types of loops in C and C++, let's see how they look after compilation and decompilation. In this section, we'll take C loops compiled with Microsoft Visual C++ 6 and decompile them using Ghidra. Launch Ghidra and open the project we created and worked with in the previous modules. Import and analyze two additional example programs available on the GitHub repository: simple loops and nested loops. Make sure to analyze the binaries as shown in Module 3 earlier in the course. Let's take a look at the functions we will be reverse engineering from simpleloops.exe example program. All of them contain a for loop, which is the first loop we will be talking about. The first function from the three functions we just saw, after compilation and decompilation, is shown on the screen. Note that Ghidra decompiled the loop as a do-while loop. The second function with for loop after compilation and decompilation is shown on the screen. Again, the loop was decompiled as the do-while loop. Now, the third one, still a do-while loop, however, it is wrapped into an if statement. Because the exit condition is dependent on a parameter, which can be any value, the compiler added an if statement around the loop, so that the loop is not executed if the condition is not met. In the previous two examples, the execution condition contained values known at the compile time. Therefore, if statement around the loop was not necessary. Now, let's take a look at the example function with the while loop. The first one is quite simple. The second one is more complex. Let's see how they were compiled and decompiled with Ghidra. Observe that the while loop in the source code was decompiled as a do-while loop wrapped into an if statement, given that the loop execute condition cannot be verified at the compile time, similar to one of the examples of the for loop. The second example is more interesting. Compiler optimized the function so that it always returns -1. Experiment executing the function on a piece of paper. You will see that it is correct optimization. Now, for the first time, we see Ghidra decompiled code as a for loop, which is not what the source code has. However, it is here in the decompiled version of the function. Ghidra has a number of heuristics when it comes to generating for loops. I guess this example matched one of them. Now, let's review the do-while loop example functions in simpleloops.exe program. These functions are quite simple as well. The first one is decompiled as expected, essentially repeating the source code. The only difference is that the array is being accessed and iterated through a pointer. Some engineers prefer to use convenience pointers to iterate arrays inside the loops instead of calculating indexes to access array elements. Microsoft Visual C++ compiler likes to do that as well. You might see such array iterations very often in code compiled with Microsoft's compilers. The second do-while loop is also very simple. Note that unlike for and while loop examples with a dynamic loop condition, there is no additional if statement, which is a sign that this loop was a do-while loop to begin with. I encourage you to experiment with the source code to make functions a bit more complex and see how that changes the decompiled output. Let's explore nested loops, where one loop is inside another loop. In a nested loop, the inner loop completes its iterations for each iteration of the outer loop. Nested loops are commonly used in multidimensional array operations, matrix operations, and printing patterns or tables. When working with nested loops, it is essential to keep track of loop counters and conditions to avoid infinite loops. Close the code browser window with simple loops and open nested loops example program. First, let's take a look at the source code of the example function with the nested do, while, and for loops. The function does relatively simple and straightforward calculations. Now, let's take a look at its decompiled representation. As you might have expected by now, it was compiled and decompiled into two nested do-while loops. Let's explore function with nested do-while and while loops. It is very simple as well, which is the intent of the example programs, to showcase one topic at a time. The function's decompiled version contains do, while, and for loops. Again, we hit one of the for loop heuristics with this simple while loop in the source code. The do while inside a do while loop example is on the screen. Its decompiled version brings no surprises, very straightforward decompilation. The nested loops example program has various examples of different loops combinations not covered in this video. I encourage you to explore all of them on your own. The source code and the binaries of the program are available on the GitHub. The link to it is in the video's description. Ghidra uses various heuristics to decompile loops, and it doesn't always preserve the original loop structure. In fact, most decompiled loops will likely to be presented as do-while loops regardless of the original loop type. However, there are some patterns to look out for that can help you restore the original loop type. For example, a loop inside an if statement can be a giveaway. You might also encounter inverted loops or loops that have been transformed into while true loops with breaks or continues. Additionally, decompiled loops might feature unusual branching and go-to statements, which can make them harder to understand. And to make matters more complex, code optimization during compilation can introduce other unusual code patterns. As a reverse engineer, it is essential to be aware of these possibilities and develop your skills to analyze and interpret decompiled loops effectively. This brings us to the end of this module. In our next module, we will dive into the world of integer number representation, especially choose component. You will learn how this representation works and how it's used in computing. We will also explore the reverse engineering of the modulo operator, which is a critical aspect of understanding how arithmetic operations are implemented in machine code. All the course materials, including code examples and exercises, are available on GitHub at the link provided in the description. I'm looking forward to continuing our journey into the world of reverse engineering with Ghidra. If you are looking to dive deeper into software reverse engineering, I'd like to recommend my book, Software Reverse Engineering: Navigating x86 Windows Applications with Ghidra. This course draws heavily from the book's content. However, the book itself contains many more examples and insights that can help developing your reverse engineering skills. The book is available in both print and digital Kindle versions on Amazon, making it easy to access and read wherever you are. Additionally, the book covers subjects not discussed in this course, such as reverse engineering of C++ programs, classes, virtual functions, and more. I encourage you to check it out. Thank you so much for watching and learning with me today. If you found this video helpful, please hit that like button and subscribe for more content like this. Your support means a lot to me. If you have any questions or topic you'd like to discuss, leave a comment below or shoot me an email. I'm happy to chat. If you'd like to support me and the channel financially, you can do so through Ko-fi or Patreon. Links are in the description below. Thanks again for watching, and I will see you in the next video.